Okay, so now I can go ahead and say, what is the weight of an object on Venus? If Venus is 1.23 times smaller, because Earth is 1.23 times larger, and we can say smaller over here. Let's go back to get the 9.81. This is step 1. Step 2, 9.81 divided by 1.23. 9.81 divided by 1.23 comes out to 7.97. 7.9, let's round that up to 8 meters per second square. That is the acceleration of Venus. Okay? So what is the weight of that object on Venus? Step number 3. Mass, which is 35, times the gravity of Venus, which I figured out from my notes and with all this information. I did the calculations. 7.98. I know this wasn't an easy question. Okay? But once in a while, we are going to have a difficult question that makes you think. That's what you're having to do here. You're really needing to think. 7.98 times 35 equals 279.3 newtons. What is the weight of this object on Earth? 343. Is Venus smaller or larger than Earth? Smaller. So this weight should be smaller on Venus. Is it smaller? Yes, it is. We did the math and calculations on our own. I promise you, you can do this. And that was station number 4. Let's go to station 5. Number 3, number 4, station 5. Use the string attached to the yo-yo and make the yo-yo go up and down. Draw a free body diagram on your paper. For 5A, though, your lap sheet, use the motion of the yo-yo going down. For 5B, you're going to draw the free body diagram of the motion of the yo-yo traveling back up. Okay? So let's go ahead and let's look at that. 5A and 5B. Here's my yo-yo. Here's my yo-yo. Do a dot in the center. Part A was for the yo-yo going down. Part B was the yo-yo going up. So on A, the larger yo-yo arrow should be going down. Smaller arrow going up. Part B, the larger arrow going up. Smaller arrow going down. So F sub G or F sub W can go here. Some of you want to put applied because like you force the the yo-yo to go down. But the moment that the yo-yo was released out of your hand or out of my hand, what happened? Weight, force, or gravity was pulling it down. Okay. Yes, it's an applied because of the acceleration of it going down, but I see that from the longer arrow. But yet my yo-yo was being held up by tension force from the string. Now over here, F sub G or F sub W, again, because we're on Earth, right? Don't forget your 2 sentences. But what about here? F sub T. I understand it was being forced up. The acceleration is moving in the upward direction. I already get that from the larger arrow. I don't need to put the F sub A here. What I do need to put is an F sub T, because if I didn't put that, I would not know that it was held up by a piece of string. Okay? Was this balanced or unbalanced? Unbalanced. Was it accelerating? Yes, it was. It was going up. This is unbalanced. I'm sorry. This one's down. Unbalanced. Yes, acceleration. Up. Let's go look at number 6. Use the string, it says here, to the black motion car and pull it up the ramp. Draw the free body diagram on your lap sheet. Identify all of the forces on this car while it's going up the ramp. Okay? So in this case, here's my car. Draw my dot. Do I draw the ramp? Do not. Now, no matter what, gravity still pulls down F sub G or F sub W. Okay? Okay, let's keep looking at this. Now, there's this board that this car is going up. So that should be my longer arrow, F sub A. But the true answer should not be an F sub A. I can tell through the size of that arrow that that's the applied force. That is the motion that it's moving. But the fact that it's being pulled by a string should be an FT. Because if you don't tell me an FT, then I'm not going to know. Opposite of the FA, in this case FT, is an F sub F. It's being held up by the board, and that needs to be where my line produces a 90-degree angle. So my F sub N normal force should be able to produce a 90-degree angle when it touches. Okay, so again, draw your, write out your sentences. This is unbalanced because yes, it's accelerating. And if you put northwest or upwards or something like that, that works. If you drew an arrow like that, that works too. Okay, we're on station 6. Station number 7. Answer the paper and attach it to the back of your lab. So let's see. Station 7 was a front and back page. It looks like this. So let's go ahead and answer that so that way we can be ready and we can go back, look at the video or look at the pictures to help you with the answers if needed. Okay? Now, let me organize my little space so we can get started.